Good morning po. Ang i-report ko po ay insect coordination and integration about regulation of muscles, contraction of insects. Regulation of muscle contraction is initiated by the arrival of an action potential at the nerve-muscle junction. At an excitatory synapse, this leads first to excitation and then to activation of the muscle fiber. Need to response nerve muscle para ma-activate yung muscle fiber niya. Innervation, characteristically in insects, each innervating muscle has many nerve endings spaced at intervals of 30 to 80 UM along each fiber. This is called multi-terminal innervation. Example nito ay nasa picture. Innervation kasi parang one for all for one. Need to supply energies and supply the nerves. Kasi alam naman natin na konektado lahat sa mga other cells. Ito pong pictures, example po ng electron micrograph of a nerve muscle junction. Itong naka-arrow naman sa mga naka-point-point, which the neuron is absent pertaining close contact between axon terminal and muscle membrane. Sinabi nito after Smith Theorem 1963. Ito yung mga naka-point-point. Ito yung mga basal lamina, blood space, synaptic vesicles, blood space. Polyneuronal innervation. Example nito ay ito yung mga functions ng mga polyneural innervation segment 4, segment 5, segment 6, and segment 7. Ang polyneural innervation kasi is a innervation of transverse abdominal muscle of the liogreus by neurons with cell bodies in different segmental ganglia. Parang polyneuronal ay single neuron innervates more than one muscle. Activation of the muscle fiber. Muscle fibers are activated by a motor neuron. So, what is muscle fiber? Muscle fiber, ito yung parang nagko-control ng physical forces, mga movements, ng mga tissues or mga limbs, etc. Example dito, ito yung parang example ng muscle ng human. So, muscle fibers consist of a single muscle cell. They help to control the physical features with the body. When grouped together, they can facilitate organized movement of your limbs and tissue. Pag ihahantulad natin sa insects to, parang same din kasi pag walang muscle fibers, hindi sila makakakontrol ng physical forces nila at yung mga movements nila. Ganon. So, magkapareho lang din. Activation of the contractile system. The invaginations of the T system convey the changes in electrical potential deep into the muscle and close to the myofibrils. Perception of the potential change occurs through the ryanodine dihydropyridine receptor complex at the DID structures. In short, ito is parang activated by the calcium ions binding to the troposin-troponin complex of thin filament. Cycle to muscle contraction and relaxation is associated with calcium release sequestration, parang removal or separation. Inhibition of muscle contraction. When a muscle spindle is stretched, the stretch reflex is activated, and the opposing muscle group must be inhibited to prevent it from working against the contraction of the homonymous muscle. Parang ito ay one muscle against group is fully contracting, then the range of motion joint can become limited. So, neuromodulation, technology that acts directly upon nerves. It is the alteration or modulation of nerve activity by delivering electrical. So, control of visceral muscles. The control of the movements of visceral muscle in the heart, ventral diaphragm, gut, Malpighian tubes, and oviducts of insect. Next topic, energetics of muscle contraction in insects. Description. Force. Force is an influence causing a mass to change its state so that it accelerates or decelerates. A muscle generates a force as it contracts because of the resistance of the object being moved. The unit of force is a Newton being applied. Tension. Tension is produced by opposing forces pulling on an object. Tension in a muscle normally rises to a peak as the muscle begins to shorten and then falls again as shortening continues. Work. Work is the application of a force over a distance or a measure of the energy transferred by a force. Energy. Energy is ability to do work. The unit of energy is the same as the unit of work, the joule. Power. Power is the rate of doing work or the rate at which energy is supplied. The unit of power is the watt. Tension and force during contraction. The tension exerted by insect muscle is not exceptional. The mandibular muscle of various insects exert tension of 3.6 to 6.9 gram square centimeter, and the extensor tibiae muscle of Decticus orthoptera is 5.9 gram square centimeter compared with the values of 6 to 10 gram square centimeter in humans. Energy is stored in the elastic system, but most of the energy stored depends on the stiffness of the muscle. Right muscle and especially vibrillar muscle as studied in Letosaurus, Drosophila, and other insects have a much higher elastic storage because they are stiffer than other muscles. Mandible of Orthoptera tension exert 3.6 to 6.9 gram square centimeter. Nakikita niyo tong picture na to, may bilog dito. Ito yung abductor and abductor pulse mandible inward. Dito sila nagkukuha ng tension and force, I think, na nagpapababa dito. Next naman, Figure 2, extensor muscle of lucus and other grasshopper. Itong malaking leg, lucus hand leg, extensor muscle much larger than flexor. Ito yung naka-blue dito, ito yung extensor. At yung naka-red, flexor, femur, flexor. Tapos, dito naman sa passive joint forces, itong nasa baba nito, strong flexion. Habang sa taas, no extension dito, no extension. Punta naman tayo dito sa horsehead grasshopper, middle leg, flexor muscle a little larger than extensor. Ito, ganun pa rin, extensor yung nakakulay blue, flexor yung nakakulay red. Dito naman, pinagkaibahan nila dito sa part na flexion naman dito. So, ano pala yung extensor? Kanina pa natin sinasabi. Extensor is a muscle serving to extend a bodily apart. Each duration of the muscle. The duration of each muscle twitch, the time for it to shorten and relax is temperature dependent. Efficient flight by Schistocerca requires a wing beat frequency of about 20 Hz with a period of 50 multiple sclerosis. Only above 30 circa, twitch duration short enough to avoid significant overlap of antagonistic muscle twitches. Some large insects such as Letocerus go through extensive futile flight muscle contraction to raise their body temperature prior to flight. Twitch duration also varies in different fiber types. Shorter the muscle, faster the twitch duration, and vice versa. Itong nakikita sa picture, ito ay actomyosin crossbridge sobonate. Itong crossbridge can only form where thin and thin filament overlap, allowing myosin to bind to actin dito. So, meaning nito, the power output of muscle. So, itong basilar and subular, ito yung directly inserted sa mga wing base ng mga insects para makagalaw sila or movement. Oxygen supply. Muscular contraction requires metabolic energy, ATP, and the muscle have a good tracheal supply. It is true of a flight muscle in which tracheal system is specialized in case flying insect. In most muscle, tracheals are in close contact with the outside of the muscle fiber except in Odonata and Blatodea. Respiration, ito yung nakikita sa respiration at cellular level, which includes muscle cells. Oxygen supply to flight muscles. The tracheals follow in navigation of the T system and penetrate to the center of the fibers. Fine tracheals less than 200 millimeter in diameter comes very close to mitochondria in the wing. Probably every mitochondrion in the flight muscle is supplied by one or two tracheals of this tertiary system, so that distance oxygen has to pass through the tissue. But in Odonata and Blatodea, the tracheoles are 10 microns. It will not reach up to the mitochondrion. So yun, kaya pala denied yung Odonata and Blattodea family kasi the tracheoles are 10 microns. It will not reach up to the mitochondria. Ganon. Example nito ay yung oxygen supply to flight muscles in Drosophila sp through tracheals. Example dito, ito yung picture ng Drosophila flight muscle. And pag pumunta tayo sa baba, tracheal outgrowth, dito sila, ito yung parang nagsiswitch in FGF, trafficking, tracheal invasion. Locus flight muscle use some 80 liters oxygen kilogram H1 during flight, and consumption by the flight muscle of some other insects may exceed 400 liters 0 kilogram. In locus, ventilation of the pterothorax produce a supply of oxygen well in excess of needs, and the specialized system of trachea and tracheals in the muscle ensures that oxygen reaches the site of consumption. Pneumatization mechanism in the tracheals near the mitochondria and tracheal intima is permeable. EK. The metabolic rates of flying insects are commonly 100 times higher than those of resting insects. So, mas maraming active kaysa sa nagre-rest insects. So, tapos na po pala, and thank you sa pakikinig.